Hi Year 10, here is the video that I promised you, showing you a few or giving you a few tips on how to do an at-home experiment with cellular respiration and some dried yeast and some table sugar, which is actually sucrose, just the granulated sugar that you buy at the supermarket. What I'm going to introduce to you today is just the pilot experiment, and then hopefully you'll be able to actually design your own more controlled experiment to test a variable of your choice as you develop the skill and some understanding of what this might look like and how you might measure it. So this is the document that you'll find in Teams, and I'll direct you to that via the posts. Have a look at this first. So there's a picture of yeast under the microscope, and have this at hand as you're going. Okay. What we're doing today is just doing a pilot experiment. You'll need some measuring devices or equipment. Now that obviously isn't a measuring cylinder or pipettes as you might find in the science classroom, but you will find that at home you've got lots of different bits and pieces with volumes and milliliters and things like that on. So today all I've got is I've got a ruler, I've got a cup measure which is 236 milliliters. I also have a Pyrex jug, which takes me up to 500 milliliters. Keep in mind that glass is not very resistant to temperature change. So a drinking glass, you mustn't pour boiling water into that. It's likely to shatter and crack. However, if you do have Pyrex measuring vessels or heat resistant glass, then that's much safer to use with hot or boiling water. The other tip is that if you are adding boiling water to anything, always put, so for example, if we're trying to warm up our yeast mixture today, put cool water in to start with and then just add a small volume, and that will mean that you're not actually exposing the glass to such extreme temperature changes. Okay. There are some risks mentioned in your document, but the other one is obviously that you are using glassware, so breaking it is a risk to yourself, and using boiling water is also risky, so please be careful with that and try not to burn yourself. All we're going to do today is make a few stock solutions, and you'll see that described in your document. As we described in class, we're just going to make a saturated sucrose solution. So I've just used a latte glass, a coffee glass, and I've used some sticky tape so that I can actually write on the side of the glass. So I've stuck a little bit of tape on here, and then I can write onto the glass and not mark the glass itself. So all of this household equipment can be used this afternoon for dinner. You just give it a quick wash and then it's fine, because these are all food products. So I'm just going to measure, mark on it the water level. I don't know if you can see because I've got green here, but and I've just kind of filled up with room temperature water, and then get pouring some granulated sugar in until I can't dissolve anymore. And what that means is that the water is almost full or saturated, and no more sugar can be dissolved into this room temperature water, and that's the point at which I want to get my sucrose solution to. So I'm at that point now, because the water's where you can actually see the sugar crystals forming at the bottom, because I've poured quite a lot. I've poured about this much sugar in, and I've stirred it and stirred it and stirred it and stirred it, and the crystals aren't vanishing anymore, so it's literally full of sugar. So that's my stock sugar solution. I'll leave it in there. In the picture for you, these are my glasses that I'm going to do the fermentation in today. And I'm just going to use 2 today, but we'll use a few more tomorrow when you do a controlled experiment. And here's my dried yeast that I've taken out of the packet. The packets are usually 7 grams each. I've emptied it out, and I'm just going to pour some water in here. So I'm just going to take it up to, I'm actually going to add some really hot water to it. I've taken it up to about 160. Tiny dash of boiling. I don't want to boil my yeast, obviously. We've talked about that a little bit in class. I'm just going to go and grab a clean teaspoon, because what I don't want to do is add any sugar just yet. So using a clean teaspoon with no sucrose on it, I'm just rehydrating the dried yeast. So I really want that to about 200 millilitres. It's not quite there. If you don't have a measuring jug, then just use a glass and mark on the glass how much water you resuspended in. But you want it to look a little bit milky, and what that means is that you've got a nice concentrated yeast broth to work with today. I put a tiny dash of boiling water out of the kettle in just to bring the temperature up, because yeast, as you would suspect, likes it quite warm. We know that we use warm temperatures when we're baking, and that helps the bread to rise. So that's what we've done today, is just warm it up a little bit and help to activate that. Now that will need to sit somewhere sunny or somewhere warm for 10 or 15 minutes at least, maybe a little bit longer if you've got that much time. Anything else we need to get ready for today? So the idea is that we're actually going to mix some yeast with some sugar and then change the temperature of that reaction. In this one I could add tap water, or I could add an ice cube, and in this one I could add really hot water and take the temperature up quite warm, and then after a set period of time I can measure the amount of reaction according to the amount of foam, or the depth of foam in centimetres on the top. So we're going to pretend that I've left that for half an hour warming up. Now, because I've got 200 mils, it's important to mix this so that you're getting the same number of organisms in each one. Because I've got 200 mils, I might try and get 100 into each glass. Now, remember, we're not doing this as precisely as we would be doing at school, but it should give you some exposure to the ideas. You should be able to control the variables to an extent and take some measurements and make some observations. Next thing I'm going to do is actually change the temperature here. So I'm going to probably grab an ice cube first. So you could use sticky tape to mark the level of the yeast. So I can make multiple little labels on the side of my glass, and I can just pull these off at the end. So I've marked the level of the yeast. I can do that on both of the glasses. Then what I'm going to do is add, I'll start with the ice. So I'm going to put 2 ice cubes in that one. And then, now this isn't going to be perfectly controlled because ice has a slightly higher volume than liquid water. But I've added a little bit of boiling water. Actually, I can feel that that's quite a nice warm temperature, probably around 30. I'm going to add another ice cube or 2, so I can add some more warm, because I'd like that to go up to about 40. There we go. No reaction is going to start yet because I haven't put the energy source in for this reaction. Now what you could use a measuring spoon, you could use a cup, or you could just use centimetres, and you could just take them to about the same level. I'm just going to split my saturated sucrose solution between the two, being really careful to leave the crystals behind. Give them both a stir. Now they've both got exactly the same ingredients in now. I've got the same reactants. I've got yeast, I've got water, and I've got sucrose, or a sugar, a substrate. This one's nice and warm, this one's icy cold, and then I'm just going to leave it. I'm going to observe. You set up a pilot reaction. I'm going to do some observations now, so I'm going to take a photograph so that I can actually see the level of my solution or my reaction, and then I'm going to have another look in a little while and see if the yeast has actually started to respire and produce any foam on the top, and then I can measure the foam using the ruler here and just measure the depth in centimetres, both here and on my cold reaction. Now the expectation would be that you have a reaction happening in this one and not in this one, at least not in the next 15 or 20 minutes. Other things that you could use to measure the rate of this reaction or whether the reaction's occurring, if you've got a bottle, as we talked about in class, you could attach a balloon to the top of the bottle, and then you can measure the diameter of the widest part of that balloon using a piece of string, and that gives you an idea of how much gas is being produced by the reaction. The other thing that you could do is using the balloon, you could tie the balloon. So once you've finished, say for example you run the experiment for 30 minutes, tie the balloon up at the end and then submerge it in a measuring device such as a jug. If you put, for example, and there's a video link explaining this process in the document, but if you put, for example, 300 millilitres of water into the measuring jug and then you submerge your balloon, making sure not to push your hands under, the difference or the amount of rise gives you an idea of the volume of that balloon. So therefore you can actually make a judgment about how much gas has been produced in centimetres cubed. Okay, so there's a number of different ways that you can actually take measurements even though you're just at home with some very basic equipment. The objective for your pilot study is really just to make sure that you can get the yeast to ferment at home. So ideally this nice warm one will start to ferment very soon and we'll start to see some bubbles appearing. That is another way that you could make an observation, is by looking for the presence of bubbles and seeing how many bubbles are appearing per minute if you can count them, but the reality is that it's very difficult to do that in a big thick glass like this. So that's another thing to think about. But if you can get the yeast to ferment and try and make some observations in the home context, then we can have the opportunity to talk about that on Tuesday and then design a controlled experiment in which you change some variables yourself, control lots of variables even at home, and be able to draw some conclusions from this little experiment here. So if you have any questions, obviously post those into the team. The document you'll find in your OneNote and also linked in the into the files in Teams, and that's about it. So have a play and let me know how you go. Well done.